Introduction. Electroplating involves passing an electric current through a solution called an electrolyte. This is done by dipping two terminals called electrode into the electrolyte and connecting them into a circuit with a battery or other power supply. When the electricity flows through the circuit, they make the electrolyte spill out, and some of the metal atoms is contained are deposited in thin layer on top of one of the electrolyte is become electroplated. All this kind of metal can be plated in this way, including gold, silver, tin, and nickel. Besides, electroplating is very similar to electrolysis to spill out chemical solution, which is the reverse of the process by which battery produce electric current. All these things are examples of electrochemistry chemical reaction caused by or producing electric that give scientifically or industry useful end product. Effect of various agitation rate is the key field for our MC lab, where we apply 3 different cathode and 1 anode and also salt solution. For our MC lab, we use 3 different cathode, which is copper, aluminum, and iron. The anode is negative or reducing electrode that release electron to the external circuit and oxidize during the electrochemical reaction. And the cathode is the positive that acquire electron from the external circuit and is reduced during the electrochemical reaction. The agitation are one of the electroplating process. The metal solution should be allowed to form a uniform, dense, and good adhesion metal layer on the surface of the workpiece.
Theory: when constant potential was applied to the electrochemical cell, current increased with increasing rotating rate of stirrer. The effect of electrolyte agitation was not significant in small interpolar distance as compared to large interpolar distance. It is recognized that decreasing interpolar distance is more effective than electrolyte agitation to improve the process in terms of production rate.
Greetings, Doctor. Hopefully you have a nice day. My name is Nawaf Omar Yahya Mashikh, matrix number AD 220169. In this group project, I'm responsible about the discussion part. So in discussion part, I will explain our experiments. So first, experiments with electroplanet. First of all, we take a piece of metal and then we clean it and polish it to remove any dirt or oil. And then we take the metal and put it into a solution. Solution contains a salt of a metal, and then the metal piece acts as the negative electron in the electro process. We take another electro called anode and put it into a solution. Then the electric current passed through the solution using a power source. As the current will follow, this process continue until the requested metal thickness as reached. And this is all the steps we use in our experiments.
For the next part, I will explain about the final result and observation in this experiment. This experiment is about the effect of various agitation rates. Before that, I will show you a video about how we conduct the experiment.
My name is Aisha. For our title for MC is effect of agitation rate for electroplating. So now for our solution, we use a salt. We take a teaspoon of salt and put inside the beaker. One.
Okay, my name is Nawaf, and today I would like to express our experience and start with copper. And we have 5 different materials. The first one is copper, and second one is zinc, and the third one is the aluminum, and the fourth is celestic, and for the last part is iron. And also we have another one is anode for the last one.
Assalamualaikum, my name is Raha. I am going to explain what we need to use. So I show you this is alligator clip. This green clip for negative, this red for positive. Okay, for first step, we connect the coin. This is we use this coin for for our anode. So we bury it. We put it in water. Don't be too deep. Just like that, so that the magnet don't touch. Scattered, we use copper. Okay, we connect with the negative clip, and then we put it inside also. Don't touch the positive clip. The positive clip. Just like this.
Assalamualaikum, my name is Fatiha. For this experiment, we use DC power supply with 12 volt to plating the anode and cathode. Okay, for the plating anode and cathode, we use different material with different stage of speed. We start with 0, 2, 4, 6, and 8.
For this part of experience, we start with zero speed, and for Cooper, I will start for 5.
The plating, we will measure the weight of this material.
First of all, as we can see in the video, we have two alligator clips. The red alligator clip, we put 10 cents as anode and place on the positive side of the power supply. Meanwhile, the alligator clip in green is the cathode, where the materials will be changed after one of them has been completed. The material is copper, aluminium and iron, and this clip is connected to the negative channel of the power supply. When the power supply is open, the stirring and electroplating process take place for 5 minutes with different speed levels starting from 0 rpm to 8 rpm. After finishing the stirring and plating process, we can see the difference in terms of weight of each material and the thickness of the 10 cents is getting thinner. This is a picture before the experiment was conducted and after the experiment was completed. The difference is very noticeable. Next is about the observation that can be observed throughout the experiment. Observation also information that can be measured from the final result that occur to each type of material used in this experiment. And it can also be seen how this process is carried out. Before this experiment is carried out, each material must be taken the initial weight. Then the weight will be taken again after 5 minutes of the plating process. This experiment is related to the effect of various stirring rate, and among the material used are 10 cents coin, copper, aluminium and iron. Therefore, we can see what will happen to the 10 cent coin after the stirring and plating process take place. That's all from me. Thank you.
Next, I will present about question and discussion part. What material should the plating bars be consisted of and why? Many plating bars include cyanides of other metals such as potassium cyanide in addition to cyanides of the metal to be deposited. This free cyanide facilitate anode corrosion, help to maintain a constant metal ion level and contribute to conductivity. Plating is used to decorate objects for corrosion inhibition, to improve solderability, to harden, to improve wearability, to reduce friction, to improve paint adhesion, to alter conductivity, to improve IR reflectivity, for radiation shielding, and for other purposes. Examples: chromium, zinc, rhodium, nickel, copper, and silver. We can use nickel as material due to its wear resistant to corrosion. Nickel is a popular metal for electroplating. Nickel plating increases product longevity and can be applied to steel as a substitute for more expensive stainless steel. What ions are present in the electrolyte? Ion that are present in the electrolyte is positive ion, that is cation, and negative ions, that is anion. Give all relevant half reaction occurring at the cathode and anode, which is my steel sample. If we take Zn and Cu as electrode, the half reaction on the anode, Zns equal to Zn2 plus Aq plus 2E minus E, oxidation. The zinc loses 2 electrons and forms Zn2 plus. If reaction at cathode is Cu2 plus Aq plus 2E negative, equal to Cus reduction, copper ions gain electron and become solid copper. Overall, reaction is given below. Zns plus Cu2Aq equal to Zn2 plus Aq plus Cu. Through your observation, explain changes that occur to the electrolyte solution during the electroplating process. When the current is turned on, positive ion in the electrolyte move to the charged electrode, called the cathode. Positive ions are atoms with one electron less. Once they reach the cathode, they combine with electrons and lose their charge. At a similar time, charged ions move to the positive electrode, called the anode. Charged ions are atoms with one electron more. Once they reach the positive anode, they transfer their electron to that and lose their electric charge. Is the final weight differences observed when compared to different types of sample and why? Yes, there are final weight differences observed when compared to different types of samples. These differences only occur in my steel and copper nickel sample. The differences of weight are due to different off-sample thermophysical properties, size, and their structure. Furthermore, effect of time also has revealed that thickness increased time. It did not seem to have a deleterious effect on electroplating results. This is in line with Faraday's second law of electrolysis. The outcome of this experiment was that when the current is turned on, positive ion in the electrolyte move to the charged electrode, called the cathode. Positive ions are atoms with one electron less. Once they reach the cathode, they combine with electrons and lose their charge. Electroplating is basically the process of plating a metal onto the other by hydrolysis. By hydrolysis at the cathode mostly to prevent corrosion of metal.
Conclusion. To conclude, we know the electroplating is a process by which metal ion migrate via a solution from positive electrode to a negative. This lab, we can see the different weight of the material after and before 5 minutes of electroplating. This is happen because of electrolysis that transfer from an anode, a part contain the metal that will be used as the plating, to a cathode, the part to be plated. Beside that, the thickness of the coin also reducing and the appearance of the coin also change. To summary, the electroplating is working and the agitation rate is successful recorded in the table.